Hello mga katangkay! Welcome to CERTS and welcome to Elementary Physics.
Rotational kinematics. Simply speaking, rotational kinematics are just an adaptation of the 1D kinematics which were discussed previously. Pero dito, instead of using linear variables, we will use angular variables. So let's start with the simplest one, the angular position. So it is denoted by the Greek letter theta, and it is a measurement of how far a particle has rotated. So, pwede nating malaman yung angular position ng isang object by following this formula. Theta is equals to S over R. So, your S stands for your arc length and R stands for your radius. And you divide those two values and you have your angular position. So, the standard unit or SI unit for angular position is it is measured in radians. Now, let's proceed to the rotational variables. So if a particle rotates about its rotation axis, changing the angular position of the reference line from theta 1 to theta 2, then the particle undergoes an angular displacement denoted by delta theta. Sa madaling sabi, angular displacement just refers to a particle's change in angular position. For example, gumalaw yung isang object since umiikot siya. Gumalaw siya from point 1 or theta 1 to theta 2, and you take the difference between those two values, you now have your angular displacement. And yun yung makikita natin sa formula natin. Delta theta is equals to theta 2 minus theta 1, where theta 2 is your final position and theta 1 is your initial position. And just like angular position, its SI unit is also measured in radians. Now, let us talk about angular velocity. So angular velocity is denoted by the Greek letter omega and is defined as the rate of change in angular displacement over time. As we can see in the formula here, omega is equals to delta theta divided by delta t, where delta theta is your angular displacement and delta t is your time elapsed. The SI unit for angular velocity is radians per second. So, paano nakuha natin yung radians per second? Remember that angular displacement is measured in radians, and we divide it by time, which is measured by seconds. Therefore, radians divided by seconds will give us the unit radians per second. Let us move on to angular acceleration. Angular acceleration is denoted by the Greek letter alpha. And again, it is the rate of change in angular velocity over time. So kung si angular velocity, rate of change in angular displacement, si angular acceleration naman, rate of change in angular velocity naman. So we can see in the formula here, alpha is equals to delta omega divided by delta t, wherein delta omega is your change in angular velocity, while delta t again is your elapsed time. So the SI unit for angular acceleration is radians per second squared. So paano ulit nakuha yung radians per second squared? Remember, angular velocity is measured in radians per second. Kaso magde-divide pa ulit tayo ng another quantity of time which is again measured in seconds. So magiging radian per second per second. Then magsasama yung dalawang second which will become second squared, and that will result to radians per second squared as the SI unit for angular acceleration. Now that we have discussed the angular quantities concerned with rotational kinematics, let us now move to its equations. So again, gaya ng sabi ko kanina, rotational kinematics is just an adaptation of the linear kinematic equations. Ang pinagkaiba nga lang nila, yung linear variables, ipapalitan natin into its angular counterparts. For example, delta x, linear displacement, papalitan natin siya ng delta theta, angular displacement. Yung v naman, linear velocity, papalitan natin siya ng omega, angular velocity. Then we have a in linear kinematics, which stands for acceleration. Papalitan natin siya ng alpha, which stands for angular acceleration. So here are the four rotational kinematic equations that are frequently used when you are solving problems related to this topic. So the definition of the variables are written below with their respective units. So the first equation is the final angular velocity of a particle is equal to its initial velocity plus the product of angular acceleration and time. Next, we have the angular displacement of a particle with constant angular acceleration is equal to the product of initial angular velocity and time plus half the product of angular acceleration and time squared. Next, we have the square of final angular velocity of a particle with constant angular acceleration is equal to the square of initial angular velocity plus twice the product of angular acceleration and angular displacement. And lastly, we have the angular displacement of a particle with constant angular acceleration is equal to half the product of combined initial and final angular velocities with time. Since we can now clearly see the analogous relationship between linear and angular kinematics, it is therefore not surprising that some angular quantities can be converted into linear ones. So tingnan natin yung linear displacement. So sabi dito, if a body rotates through an angle theta, the point moves along an arc with length s, also known as its linear displacement. So tingnan natin yung formula. S equals r theta, where theta is your angular position and r is your radius. So seems familiar, di ba? Dahil ang formula na to is just a derivation noong formula natin kanina for angular position. Pero dito, ang tinitingnan na natin is yung arc length, yung s, dahil iyon ang magsisilbing linear displacement natin. So, ang gagawin natin, we multiply the radius by the angular position and this will yield the arc length, which is measured in meters. So kung nakuha natin sa previous slide ang linear displacement from angular quantities, therefore posible rin nating makuha ang linear velocity and linear acceleration. So punta tayo sa velocity. So ito yung tinatawag nating tangential velocity. So sabi dito, it is also known as the linear velocity vector. It is always tangent, as the name suggests, to the circle around the rotation axis. So kung titingnan natin yung figure, kung yung bilog is yung circular path na tinatahak ng object, we can draw a tangent line from a certain point called P, and that will serve as our linear velocity vector. So we can determine the tangential velocity by this formula. V equals r omega, wherein r is the radius of the circular path and omega is your angular velocity measured in radians per second. So yun yung lagi natin tatandaan pag tangential velocity. And another fact, kung titingnan natin maigi yung figure, yung tangential velocity is always perpendicular to your radius, meaning it forms a 90-degree angle. Always yon. So an alternate way to express a particle's rotational velocity into its linear equivalent is by using its frequency or period. So yung frequency and period, yung mga concepts na yan, pag-uusapan natin yan ng mas malalim in lesson 4 in uniform circular motion. However, if we apply those concepts, we will also have another formula nga for tangential velocity, which is V equals 2 pi r divided by t, which is also equivalent to 2 pi rf, wherein V is your linear velocity measured in meters per second, r is your radius measured in meters, t is your period measured in seconds, and f is your frequency measured in per second. Ngayon, nakuha na natin yung displacement and velocity. Punta naman tayo ngayon sa acceleration. So ngayon, yung linear acceleration, meron siyang dalawang types, tangential and radial. So punta muna tayo sa tangential acceleration. So tangential acceleration is a component of the linear acceleration which is tangential to its path and is responsible to the change of linear velocity's magnitude. So, kung titingnan natin yung figure sa may bandang kanan, makikita natin yung dilaw na arrow, tangent ulit siya dun sa circular path ng object from point P. Ibig sabihin, that is your tangential acceleration. And we can obtain tangential acceleration by this formula. A sub t is equals to alpha times r, wherein alpha is your angular acceleration measured in radians per second squared, and r is your radius measured in meters. Therefore, its SI unit is meters per second squared. And then we have the radial acceleration, which is the last concept for this lesson. So, kung si tangential acceleration is tangent to the circular path, si radial acceleration naman is a component of the linear acceleration that is responsible for the direction change of linear velocity. So, kung titingnan naman natin dito sa figure, yung red arrow, that is your radial acceleration, and makikita natin, inward ang kanyang direction. Lagi siyang nakatungo papunta sa center. And this concept, the concept of radial acceleration, ay very useful kapag iintindihin natin ang concept ng banking curves na pag-uusapan din natin sa lesson 4. So, we can obtain the value of radial acceleration in this formula. A sub r is equals to omega squared times r, wherein omega is your angular velocity measured in radians per second, while r is your radius measured in meters. Therefore, your SI unit for radial acceleration is the same for tangential acceleration, meters per second squared pa rin. And another thing na pinagkaiba pala ni tangential and radial acceleration is that si tangential acceleration, responsible siya sa pabago-bagong magnitude ng linear velocity. Pero si radial acceleration naman, responsible siya sa pabago-bagong direction ni linear velocity. So, yun. And that concludes our lesson 3. The angular position of a point on the rim of a rotating wheel is given by theta is equals to 4t minus 3t squared plus t cubed, where theta is in radians and t is in seconds. So first, what are the angular velocities at t equals 2 seconds and t equals 4 seconds? So, madali lang ang gagawin natin dito. Since binigay sa atin is yung function noong displacement or rotational displacement. So, ang hinahanap is angular velocity. By the same logic kanina, we can find the angular velocity as the of the displacement. So, we find omega is equals to d theta over dt. So yan, so we find the derivative of this equation. So this will become 4 minus 60 plus 3t squared. So ito yung derivative nung natin. Ito yung derivative nung angular position function natin, and this will be our function for angular velocities. And ngayon, ang gagawin na lang natin is we substitute 2 and 4 into this equation. So W2 and W4. So, ibig sabihin, isa-substitute natin yan. So, i-substitute natin. So, 4 minus 6 times 2 plus 3 times 2 squared. This will yield 4.0 radians. So, yan. So, i-substitute lang natin yan parang function sa GenMath. Ayan, ganyan. So, substitute natin. And we affix the SI unit for angular velocity, which is radians per second. Same procedure. So this time 4 naman ang isa-substitute natin. So we use 4 minus 6 times 4 plus 3 times 4 squared. And we do the arithmetic, and this will yield 28.0 radians per second. And yan. And our angular velocities. So yan. So di ba madali lang? So ngayon, ang hinahanap naman natin is for the next question, what is the average angular acceleration for the time interval that begins at 2 and 4 seconds respectively? So we recall the formula for average angular acceleration, that is denoted by alpha is equals to the change in angular velocity divided by the change in time. So, since 2 and 4, alam natin yung values niyan from the computation kanina. So, we just substitute them. So, 28 minus 4 radians per second. So, please take note na lang. 28 minus 4 divided by 4 minus 2. So, this will be 24 over 2, and this will be 12 radians per second squared. And that is your angular or average angular acceleration. So, yun lang. So, ganun like the question. What are the instantaneous angular accelerations at the beginning and at the end of this time interval? So, excuse me. So, kung kanina ang ginagamit natin para sa para sa average angular acceleration para naman sa instantaneous angular acceleration, ang gagamitin natin is the function or etong function itong 40 minus 3t squared plus t cubed. So ito yung gagamitin nating function. So we recall that angular acceleration is the second derivative of your angular position or d squared theta over dt squared. So in other terms, pwede rin natin siya i-define as the first derivative of your angular velocity with respect to time. So since alam naman natin yung angular velocity function natin, pwede naman yun nalay gamitin. So we find the derivative of 4 minus 6t plus 3t squared, and this will result to, so 4 is a constant, so cancel na yan. So this will result to negative 6 plus 6t. So yan. So yan na yung derivative natin ng angular velocity function. And same process kanina, since nakuha na natin yung derivative, i-substitute naman natin siya ngayon dito sa values na 2 and 4 kasi same time interval naman yung hinihingi. So alpha 2 and alpha 4 naman. So dito, ayan. So 6 minus negative 6 plus 6 times 2, that will result to 6 radians per second squared. So take note, radians per second squared is our SI unit for angular acceleration. And then, isubstitute naman natin yung 4 dito. So, alpha 4, negative 6 plus 6 times 4. So, that's times 4. So, that's negative 6 plus 24. And that will be 18 radians per second squared. Ayan. So, ganyan lang kadali yung mga ginagawa natin sa rotational kinematics, especially kapag ang hinahanap lang natin is yung angular position, acceleration, and yung angular velocity. A flywheel with a diameter of 1.2 meters is rotating at an angular speed of 200 revolutions per minute. So, what is the angular speed of the flywheel in radians per second? So, this is just a simple problem on conversion. So, if you recall the dimensional analysis na ginagawa natin in the previous session, so we write omega is equals to 200 revolutions, 200 rev per 1 minute, 1 minute. So times 2 pi rads, since there are 2 pi radians in a 1 revolution, so over 1 rev. And then again, we multiply it by 60 seconds. So nasa ibabaw pala ang 1 minute. Nasa ilalim siya kanina. So yan. So 1 minute over 60 seconds. So yan. So this will cancel, the revolutions will cancel, the minutes will cancel, and matitira sa atin is radians per second. So we multiply 200 by 2 pi and then divided by 60, and that will yield 20.9 radians per second. Ayan. So ayan na, na-convert na natin ngayon ang angular speed. So, ano naman ngayon ang gagawin natin if we are to find the linear speed? If you have read the lecture material, meron tayong formula natin or para ma-relate natin ang angular variables sa linear variables. And magagamit natin ang formula dito na linear velocity is equals to the angular velocity times the radius of the object. So, What we will do here is we multiply 20.9 radians per second and we divide it by 0.6 meters. Saan nanggaling yung 0.6 meters? So, you have to take note that sinabi sa problem, diameter daw yung 1.2 meters. And therefore, ang kailangan lang natin is radius. So, therefore, we need to divide 1.2 by 2. So, we will get the 0.6. So, we multiply it and we will now get 12.5 meters per second. And that is the linear speed of the flywheel. So, yon. So, di ba mabilis lang or madali lang? And for the third sub-problem, so hinahanap naman what constant angular acceleration in revolutions per minute squared will increase the wheel's angular speed to 1,000 revolutions per minute in 60 seconds. So, ang gagamitin naman natin dito is the rotational kinematics formula. So what we will do here is we use the final angular velocity minus initial angular velocity is equals to uh, the angular acceleration times time. So ito yung kinematic equation na gagamitin natin. And then we manipulate this variable or this equation since ang hinahanap natin is angular acceleration. So we isolate it. So alpha will be equals to the final or the change in angular velocity divided by time. So yan. So yan yung working equation natin. So we subtract 1,000 revolutions per minute since yun yung final or yun yung final angular speed na kailangan natin minus 200 revolutions per minute since yun yung given sa atin. Hindi na natin kailangan mag-convert into radians per second since magamukha naman sila ng units. And ang hinahanap sa problem natin is revolutions per minute squared. So yon. So we divide 1,000 minus 200 by 1 minute. Kasi ang kailangan daw mag-increase yung angular speed to 1,000 in 60 seconds. And we all know that 60 seconds is equal to 1 minute. So yon. So 1,000 minus 200 divided by 1 minute, it will result to 800 revolutions per minute. And that is your revolutions per minute squared. So yon. So that is your constant angular acceleration na kailangan. So for the last sub-problem, may nahanap how many revolutions does the wheel make during that 60 seconds. So we again use another rotational kinematics formula, that is theta is equals to the initial angular velocity times time plus 1/2 alpha or angular acceleration t squared. So yan. So we substitute again our known values. Since theta naman yung nahanap natin and isolated na siya, we don't need to do any more manipulation. So we multiply 200 rev per minute. That is your initial times 1 minute plus 1/2 800 rev per minute squared is your acceleration, rev per minute squared, and by 1 minute squared. Ayan. So, you multiply all these values. So, 200 times 1 plus 1/2 times 800 times 1. So, this will result, dito lang natin sa taas isulat. So, 600 revolutions. So, yun yung number of revolutions na magagawa ng wheel habang tumataas ang kanyang angular speed from 200 to 1,000 rev per minute in 60 seconds. So, yon. So, 600. So, our final answers for these problems are 20.9 radians per second, yung angular speed. Linear speed is 12.5 meters per second. And the angular acceleration should be 800 revolutions per minute squared. And the number of revolutions made during 60 seconds is 600 revolutions. Ayan, so that will be our answer for this. A merry-go-round rotates from rest with an angular acceleration of 1.5 radians per second squared. So how long does it take to rotate through the first two revolutions and the next two revolutions? So, ang gagawin naman natin dito is, so ang gagawin lang natin dito is just a simple application of, again, the rotational kinematic equations. So, what we will do in this equation is, since ang hinahanap is time, so what we can do is use this formula. So theta is equals to the initial velocity times time plus 1/2 alpha p squared. So yan. So ito pwede natin gamitin and i-derive natin siya mamaya. So first, we have to find the values. So theta automatically be 4 pi rads. So bakit siya naging 4 pi radians? Dahil ang hinahanap natin ng una is the first two revolutions. So ibig sabihin, since there is 2 pi radians in a revolution, if you multiply it by 2, 4 pi radians. So 4 pi radians is equals to 0 radians per second because that is your initial velocity since nagsimula siya or nag-rotate siya from rest. So times t plus 1/2. What is your angular acceleration? 1.5 radians per second squared times t squared. So yan. So since 0 siya, cancel na yan. And manipulating this working equation, this will result to the value of time can be solved for or using the square root of 2 theta over acceleration. So kapag inano natin yan, kapag sinubstitute natin yung value, this will be 2 times the 4 pi radians over 1.5 radians per second squared. 1.5 radians per second squared. So yan. So ito yung equation natin. So this will be 8 pi divided by 1.5. Then you find the square root and this will result to 4.09 seconds. So ibig sabihin, to cover the first two revolutions, it will take 4.09 seconds. Meron pa kasing isang hinahanap. So the next two revolutions naman. So since nakadalawa na siyang nung una and susunod, meron daw susunod pang dalawa, so 2 plus 2, that will be 4 revolutions. And then you convert 4 revolutions into radians and that will be equal to 8 pi radians naman. So same process ulit yung gagawin natin kanina. So this will be 8 pi rad. So equals again 0 rad per second. Then hinahanap ulit natin yung time plus 1/2 1.5 radians per second squared. So yun yung gagawin natin ulit times t squared. And then we use again this formula that t is equals to the square root of 2 theta over alpha. So substitute natin yung known values. This will be 2 times 8 pi. Since 8 pi na siya ngayon, 8 pi radians divided by 1.5 radians per second squared. So this will be the square root of 16 pi divided by 1.5, which will result to 579 seconds. So ibig sabihin, para ma-cover yung 4 revolutions naman, it will take the merry-go-round at least 5.79 seconds. Excuse me. And for the final step, since ang hinahanap lang is how long does it take to rotate through the first two revolutions and the next two revolutions, ibig sabihin yung time interval lang between the first two and the next two. So kumbaga yung parang third and fourth revolution lang yung hinahanap natin. So what we will do is we will subtract 5.5 5.79 seconds by 4.09 seconds. So yan, so we will subtract 5.79 from by 4.09 and this will result to 1.70 seconds. And that is our final answer. So ibig sabihin from the second revolution up to the fourth revolution, it will just take 1.70. Thank you for listening. I hope you learned something today and see you on the next discussion video.